And this serial again in the fall semester. We appreciate your suggestions and the comments. Here, I'm going to put the link to the pre-survey. Okay. If you haven't done that, please do. And you must have received my email. Oh, Cynthia, does the recording starts? Okay.
It's on, it's going.
Okay. So you must have already received our email yesterday. We are going to use the data from last week. So I will quickly walk you through the process. So here is the document I attached with the email. That's the instruction for people kind of missed the first 3 sessions. So the first step, install Rnr Studio, and here you can find the documents, the installation guidelines, and then you can you can open RStudio and type in this command line to install Tidyverse, which is the collection of packages we use in this serial. And if you're using RStudio, you can create an RStudio project, follow these steps. And here on this Windows, you can select the location of the folder you want to put the project. And then this directory name will be your project name. That will be your project folder. When you click Create Project, and you will see the in the console area on the top, you will see this path, this directory. That will be your working directory. And also you can use the command get wd and to get your current working directory. And then you can create an R script. And you can put all your scripts in that file. Can first create the 2 folders. We're going to use those 2 folders, one for scripts and one for data. And then you can download the file from Figshare using the download.file command. And here it specifies where the file will be and the file name is. And the mode is WB, which means written binary. And after we installed the package Tidyverse, we have to load it before we can really use it. To load a library, we use the function library. Every time when we start an R session, we need to load the library we want to use. And this command, read_CSV, will read the file we downloaded to our environment, and we assign it to the object interviews. And this line, we don't really need it, so you can delete it from the instruction file. And here is a section, kind of reshape the data, and for today, for the plotting. So, okay, I will walk you step by step. So first, I'm going to open my RStudio project. Okay, I will create a new R script. And okay, so let me try to have them side by side. Okay, so as I just opened this file, so I need to load the library tidyverse.
Hi, Jing. We're just getting some questions about where to find the document that we're using to copy and paste. And that should be in the email Jing sent, so that the email that also has your Zoom link. So that would be all in the same place. Kathy, did you find it? Do I need to re-email it to you maybe?
Could I put it just in?
Yeah, if you have it available.
Let me see.
Okay, I might have it too. Hold on, Jing.
Oh, I don't think it's sent out correctly.
Okay, let me grab that then. I think I can drag it over there.
Okay, so Cynthia, you may need to send that file to Kathy by email.
Okay, I will. It's in a Word doc. Can you not open Word docs? Because that's what I'm going to email you, Kathy.
Mhm.
Yes, okay, I'm gonna forward it now then. And I think I will drop it here and see if I can get it to attach.
Oh, yeah. Mhm.
And let me see. Okay, go ahead, Jing. I'll get her taken care of.
Okay, thank you. So as we already have, actually you can see my working directory, and you can also see my folder. I already have the clean data here, and so I can start read the file. So I can just copy. So I read the file in, and then I can. And so you can see that this data set, it has 131 observations, which are rows, and 14 columns, that's variables. So then we are going to do the reshape part. I just copy them here, and then first I remove this part. I want to show you step by step. So first we can take a look at the interview data set. We can use the function view. Interviews to open the tab. So we can see the 14 columns and over 100 rows. And among those rows, There are two rows. One is called items owned. Another one is month lack of food. Those two rows are kind of a little bit different from other rows. Some cells, they have more than one values and separate by semicolon. So we want to expand those values and make each value a column. Then we can calculate how many items each family or each household owns. And we want to see how many months they are lack of food. So to do that, this is the code. This is kind of the piece of code. And first thing, we will separate rows. We will handle the items owned first. So we will separate rows using the function separate rows. So I will send them to view. When I run this line, you can see this dot, which means current, the current result. So before you saw the bicycles and television and other items are in the same line, but now they are separate into different rows. We can take a look, let's say, as this data set is a little bit tricky. So we start with the third and the fourth lines. We can see here in the line 3, we have only one item. In line 4, we have 1, 2, 3, 4, 5 items. So after split rows, we can see 3 has 1 row and 4 has 3, 4, 5. We have 5 rows. So which means the 5 items are split into 5 rows. So this is what this line is doing. And then, okay. From here, we can see some families, they don't have anything. They don't have any items. So that will be NA. We want to replace this NA with items, no listed items. So which will make the meaning, it's more meaningful. And we can put it here. And then when we run this part, we can see from here, no NA, and we see no listed items. And next, we are going to use the pivot wider to expand the column into rows. So we can take a look. Oh, not this. Here, this is kind of explain how this function pivot wider works. The first argument of pivot wider is the data frame. And the second one is the names from, and which will be the column we're going to use. In our case, that will be the items owned. And it followed with the values from. It is also another column. And we add, we don't really have this item, this row in this column in the data sets. We need to manually add this column and assign true. So when it converted to the wider format, the true will filled if the column name is the item in the same row. So this is how this becomes this. This is output. So in our case, we add a new column called items owned logical. And then we use the pivot wider to expand. And instead of using NA like here, we replace the NA with false. We're using the argument values field. So we can take a look what we get. So now we have.
Jingjing, we have a question. What's the percentage more than percentage? It's Control Alt
M.
M.
Okay.
Thank you. Sorry.
The function for this is called pipe. It kind of sends the pipe is in RStudio. It will send no. It's in RStudio you can use the shortcut Shift Control M if you for the Windows, and if you use the Mac, that will be Shift Command M. And pipe will send the output of a function from its left to the next function on its right. So that way we can combine multiple functions to create a workflow to finish kind of more complex data wrangling. We will use it today. Okay. So, oh yeah, we're going to take a look at this. Oh, let me see. It seems like I didn't run it. I'll run it again. And then, okay, so then we can see first the column items owned disappears, and then all the items are expanded to column names, and they filled with false and true. So it starts, the first column is bicycle, the last one is car. And no listed items in the middle. Okay, so our purpose is to calculate how many items each family or each family has. So we will use the function mutate item number. We will use that. Let's say, okay, if I put it here and then add we will see a number of items added here. Okay, so this part follows that will handle the month's lack of food. After we run the whole part, and we will get the results. Okay, the reason why. Okay. And then this will be the results. Oh, let's do it again. Oh, I didn't send it to view, so that's why. Okay, so you can see number of months lack of food. Okay, I guess I missed one pipe. No, the pipe is here. Oh, number of items is added here. It's still added here. And I think, oh, I want to remove this one. The reason why is because I want these two columns side by side. It will be easier for us to look. Okay, so we have number of items. We have months lack of food. When we assign this to interviews plotting, oh no, not this, sorry. Here. Okay, yeah, when we assign it to this, we will see a new object created here. Instead of 14 variables, it has 45 variables. And then we can write it to the file. But before we do that, I will show you something I noticed today. There is a mistake in this code. Okay, here we know some families doesn't have any items, so it is NA. But here we did not see any 0 here because when we count the number of items, we also count this list. We see true here. So in this line, that family will have one item, but actually they don't have any items. Okay. To fix that, we can fix the code. First, we can take a look at, we don't want to include this. So we can, the one before that is motorcycle, and the one after that is fridge. So we can separate this to correct. And then we can view this here. Here we see zeros. So this line the no listed items is true here. So you can fix your code this way. And then you can copy this. If you don't have this folder, you can create this folder and you can write your CSV file. that will update your current CSV file in the folder data output. I will send out the correct code when the recordings are ready. So this is kind of what we got last week. And I will do a quick review of what we covered last week. And last week we talked about data wrangling. We used the function in R packages, the dplyr and tidyr. So the first two, select and filter, they are subsetting functions. Select is to subset columns, and filter is to subset rows on conditions. And mutate is to create new columns based on the existing columns. And group by and summarize, we use that to create the summary statistics on grouped data. And arrange is to source results, and count, we count the discrete values. And we just saw pivot wider, and pivot longer is just to reshape the format to the longer format. And we also covered the pipe operator. We use that to combine functions. Do you have any questions? Or do you get the data ready? If yes, could you use the reaction? So we're going to start talk about today's content. That's Ggplot 2. Ggplot 2 is a plotting package like dplyr and tidyr. It is a package in the package collection tidyverse. And Ggplot 2 is an implementation of grammar of graphics in R. Gg means grammar of graphics. In the package Ggplot 2, all the graphics are built using the layered approach. So layers are built up one by one to create the final graphic. Each chart built with Ggplot 2 must include at least 3 components. Data, that's the data we're going to plot. Aesthetic mapping. Aesthetic mapping describes how variables are mapped onto the graphical attributes. And geometric objects, that's kind of how values are rendered graphically. So we can create a command template for those 3 basic commands. So the function we're going to use is Ggplot. It's not Ggplot 2. Ggplot 2 is the package name or the library name. Ggplot is the function. And the first argument of the function is data, which is also our first must-have component. The second argument is mapping. We use the function AES, aesthetics, to define this, this part. We can select the variables to be plotted and specify how to present them in the graph. For example, it can be XY position, or it can be size, shape, color, or transparency. So this is the kind of the second must-have component. The third must-have component is the geometric object, which graphically represents the data in the plot. It can be points, lines, bars, or other chart types. So we call them geom. And we are going to see some common geoms today, including, let's say, geom point is for scatter plot. We're not going to see geom line, we're going to see geom bar. That's kind of the bar chart. And geom plot, that's the box plot. That's the box plot. And also we can use pipes in the template. So with pipe, we kind of start from data and send data set to Ggplot. Mapping is the second argument, and then followed with the geom function. And we use the plus sign to connect geom function and the Ggplot function. So same here in the template, we use plus sign to connect different layers. So next, we're going to see our first example using Ggplot. I'm going to use this same file. If you haven't created any R scripts, you can create one now. And first, we can put some file information, let's say title. Today's date. And you need to load the tidyverse if you haven't. And then before we start our first example, we can create, let's say, a section. In RStudio, I just use Control-Shift-R. And then I just call that first example. So the data we're going to use is the interviews plotting we just created. So we will read interviews plotting. Okay. Oh, sorry. And instead of data, this time we use from data output. And then the file name is interviews plotting.csv. Working directory. Data output. Okay, sorry. I think it's called output. Okay, when we read in the data, it tells us we have 5 character variables, 8 double variables, 31 logical variables, and 1 date and time variable. I don't need this interview anymore, so I can remove it. But I can put it from here. RM, which means remove, and it disappeared from the environment. So we are going to use the function ggplot to visualize the data. So first, we put the interviews plotting, and we use the pipe to send it to the function ggplot. We can take a look. Ggplot, I mean the interview plotting, the data is the first must-have component. It tells us the data we're going to use, but it didn't specify which variable we're going to plot and what chart we're going to use. So it displays only the gray background in the plot tab. And we can add another component, which is the mapping. We will specify X and Y. This time we're going to use two continuous variables or two numeric variables. One is the household numbers. Household member, the number of household members, and Y will be the number of items. We can take a look now. So this time we specified the x-axis and y-axis, so we can see x-axis and y-axis. But we did not specify the chart type, so it won't display. It could not display the elements. As these two components, as these two variables are continuous variables, we can see the relationship between them. We can use Ggplot. So we can plus the geom for the scatter plot. That will be geom point. So we got our first graph. Okay. So we can look at this code. This line geom, anything we put in the geom function, let's say the x-axis and y-axis, can be seen by any geom layers. So this setting is kind of the universal plot setting, global. This is global setting. And it followed with this geom layer. We can also specify mapping here, but that will be local for specifically for this geom. And we use this plus sign to connect ggplot and the geom function. The plus sign must be at the end of the line containing the previous layer. If we put it at the beginning of the next layer, and we will get an error message. Okay, yeah. One more thing to mention is the indent. Some of you may have experience with Python. And in Python, indents have syntax meanings. But in R, we use indents to make the code easy to read. It doesn't have any syntax meanings. So we can just put everything into one line it still works. This is kind of our first example. Do you have any questions? Or are you still follow along?
James, go ahead and ask your question if you want. You can drop it in the chat or unmic, and then you can just verbally ask it.
The code doesn't work.
I think it has to have no members, right? It should have an S on the end of the X axis there. So it should say no members with an S. And you only have, oh wait, it's there on the other side. It's on the, yeah. And
so now it works. Oh, Geom point. When you put the, okay, when you put this part into Geom point, it works. Otherwise, it won't work.
is that right?
No, I didn't see the.
Oh, excuse me. The code worked, but when I included a plus sign and the Geom point, that doesn't work. So, and I'm using R, not RStudio. So I'm thinking maybe the code is different.
No, I haven't. I don't really have experience using R directly. So,
Yeah, maybe the code is slightly different because the RStudio to the
I don't
R.
think it's.
You don't
I don't
so?
think it's for RStudio specific.
Okay.
Okay. All right. Thank you.
Okay. So in the first example, we kind of start by defining the data sets, and then we lay out the axis, and then we choose the geom. So typically when we build Ggplot, when we build plots using Ggplot 2, it is kind of iterative process. We can take a close look at this graph. We know that we have 131 rows observations, but the plot doesn't really have that many points. And also, as our two variables, number of household members and the number of items, they are all whole numbers. So we can see those dots appears only at the intersections of the whole numbers. And we may guess that some points are probably on the top of others. So there are mainly two ways to solve, or at least alleviate overlapping issues. The first one is changing the transparency of the points. The second one will be jitter the location of points. So we will start with the first option. So we will change the transparency of the points. When we say the transparency, we mean the opacity of points. So we can control the transparency using the argument alpha. And the value of alpha, it range from 0 to 1. And the lower the value, the more transparent the color. So alpha 1, that's equals to 1, that's the default value, and which means that's opaque. And if we set alpha equals to 0.5, which means it will make the point kind of a half of opaque as a normal point. So if we have 2 points overlap to each other, and that will make a normal point. So anyway, when we add this transparency, so we can see some points looks lighter and some looks darker. It helped a little, but not good enough. So we can try the second option. Jitter. Okay, I just copy the codes. That will make my life easier. And instead of geom point, we're going to use geom jitter. Okay. So it basically kind of move the points a little bit away from its original location. So you can see they are kind of gathered together, but not really overlap to each other. Also, geom jitter allows us to specify the amount of those motion or those random motion using 2 variables, width and height. By default, the width and height are 40% of the resolution of the data. If we want them to be less spread, we can change it. So let's say we change it to 0.2 instead of 0.4. It's not necessary those 2 values are same, but I just assign them the same. So you can see they kind of get together closer than the previous plot. And also we can combine these 2 methods. We can add the transparency to geom jitter. So we can see some points getting lighter, and then some they kind of spread a little bit. We can also change the color. Let's say we assign color to blue. We can also use color. We can also use kind of some variable to color code the points. Let's say we use village. We know we have 3 different villages. And so we want to display those points by village, display them in different color. As village is a variable, not a kind of the color, we need to put them in mapping. We can also add a treat line, add another layer. For treat line, we want to use geom smooth. And the method we're going to use is LM, that's the linear regression. we just mentioned the mapping we put in the global or anything we put in the Ggplot function will be seen by all the layers, all the geom layers. And the shaping, the mapping in the geom, on the geom layer, on each geom layer will be locally seen by this geom only. Let's say this color, village color, 3 different colors can be seen only by jitter, not smooth. If we want to display 3 trend lines, and we can add this trend, this mapping to geom smooth. Now we get 3 trend lines. Another way to do that is we put them in the Ggplot function. Oh, we don't need the whole thing. We need only color. And we don't need those anymore. When we run it, we will see the same results. You can see this is the last one. We put the color into the Ggplot2 function, and this is the previous one. So you can use this backward and forward to look.
So, Gigi, we have a question about the purpose of making the points closer. So the difference between geom jitter instead of geom point.
Geom point, they will each point will display exactly on the point, on the location, and jitter will kind of move the points a little bit around the original spots. So we can see here, if this one we use geom point, we will see less points. You can see they are on the intersections of the whole numbers. And if we use the jitter, it will move it around. You can see this too. It's not the they must have the same X and Y, but they are jittered, randomly jittered. So they will move around the original point. So this way we can kind of see the overlapped points. Does that help?
Yes, thank you.
Okay, so it's 2:55. We can take a 5-minute break. Okay, it is 3 o'clock. So if you are already back, could you kind of use the green check mark in the reaction session? Okay, so during the break, I just used my R console to run the commands. So it seems like it works. So James, if you still have any questions, and we can talk about later. Okay. So before the break, we talk about the iterative process of creating a visualization. So we saw an example of scatter plot to present the relationship between two continuous variables. So next we will see another example for box plot. Box plot, we can use box plot to visualize the distribution of items. So first we can create a section, Control-Shift-R, and then we just call it box plots. So we still start from interviews plotting, and pipe. So this time we're going to see the distribution of numbers of items. So we are going to set the y-axis equals to number items. And then plus the geom we're going to use is Geom Box Plot. So here we see a box plot. The box kind of ranges from 25th to 25th to 75th percentile. So it's kind of contain half of the observed data. The difference between 25th and 75th, or the height of this box is kind of known as IQR, interquartile range. The line in the middle is the median. And the line extending up or extending down, that's kind of 1.5 IQR of the box. We call those whisker. So this one is the outlier. We can also see the distribution of items for each village. So that way we can add an x-axis. Then it displays 3 box plots. So here we can see that the residents in the R village tend to have more items than the other two. We can also add the points to the box plot, so we can have a better idea of the numbers of measurements and its distribution. So for here, we can expand this. Let me see. we can add another layer. So we see all those kind of overlaps. And if we want to kind of jitter them, this is how they look like. So you can see the difference between point and jitter. This time we kind of put the box plot first and then jitter. If we change the order, let's say we move box plot down. We will see that the jitter is plotted first, and the box plot kind of on the top of jitter. It hides some points hidden behind the box plot. So when you work on your own projects, you should think over which should come first. Okay. And next one, we are going to talk about bar charts. For the scatter plots, when we have two continuous variables, we use scatter plot to show the relationship between those two variables. And for the box plots, we can have one continuous or one numeric data and one categorical data. So village, which is the categorical, and number of items, that's numeric. And bar chart is very kind of useful when we visualize categorical data. So by default, Geom bar accepts a variable for X and plot the number of each value of X in the data set. We can use the respondent word type as an example. So first, we still use the same data set. So we can see the 4 bars represent the counts for each word type. And here we can use the fill to change the color. Let's say we want to we use village to fill the color, and it's stacked to each other. That's stacked bar.
Jingjing, can we just do a quick recap of how to insert a section?
Insert a section. Okay,
Yeah.
that's Control Shift R. or you can just type. You can type the hashtag and then followed at list 4-. It will create this. And then you can put the title here. And whatever you put here can be, oh no. Okay, can be folded.
Yes.
But
Thank
not
you,
that one.
Jing. I think we just needed that little recap. Thanks.
Sorry, so for the box plots,
Mhm.
how could you collapse the box plots? I mean, I clicked Control Shift plus the R, but it just show me the dashed points. I couldn't collapse it. So what do you do?
Did you see this
Okay.
triangle?
Okay, I got it. Yeah.
So here we got this stack bar. But sometimes stack bar are not easy to read as the side-by-side bars. So we want to put them side by side. We can use argument position. So when we add position and we assign it to, by default, it's stacked. And we can assign them to dodge. And then it becomes side by side. So wall type is the categorical data. And we just mentioned bar chart is very useful to visualize the categorical data. It also can be used to visualize the numeric data. Let's say rooms. And so we see those bars. It's kind of the x-axis. It's kind of a room with a house with 1 room, house with 2 rooms, 3, 4 until 8. And here is the counts. So we have over 70 houses. It has only 1 room, and we have kind of 30, a little bit more than 30, but not 35. So houses with 2 rooms. So it is still counts, but sometimes we want to see as the variable we're using is numeric data, we want to see the sum, the total. Let's say how many rooms in total. So for the for this column, it will be doubled. The number will be doubled. For this column, that will be tripled. Because this is the number of houses. If we want to see how many rooms, as we know, each house has 3 rooms, so this bar will be tripled, and this will be 4 times. And Geom bar offers a feature, so we can use the argument identity to do the calculation. But with the stats identity, we have to use another variable. We have to set the y-axis. This will be the variable we use. We want to count, we want to total, we want to sum. For our case, it's still rooms. So we see this bar is kind of doubled in size. It's currently between 60 and 70. And before it's kind of here, 30 something, but not 35. So. The reason why I kind of talk about this identity, because we sometimes want to calculate, let's say we want to display the number of rooms, say by the group by the wall type. So this be the wall type, and this will be the number of rooms instead of counts. And also another application is kind of related to our first example. In this example, we use count for the kind of the height of the bars. But sometimes we want to see the percentage proportion of each housing type in village. So we can use this identity instead of just use the default one that counts. Okay, so we can start from this code, but we know this time we are going to use that identity. And we know we need and why. Let's say we call that %. We did not put them in the quotes because this is a variable. It's not a value. But we don't have this variable. We need to set it up. Okay. So first, we still start with the data set, and we want to calculate the okay, we want to count the number of by village and by the respondent wall type. Okay, we can use the function count. And then we want to group them. We want to group them by the respondent wall type. Okay, we can take a look how the values look like. Okay. So when we count the respondent wall type and the village, we got this. We got this. This is a table. It's a 10 by 3 table, and we have 3 columns. And this n is the number of observations and let's say the number of houses in this C village, and it's built with burnt bricks. When we group them by respondent wall type, and we want to calculate the when we kind of calculate the percentage, we use the each number divided by the total. So that's way we will get the percentage. Okay, so we will send the data to, we will add a new column that will cause percent. That will equals to n divided by n. As we want them to be the percentage, I think that should be right. Put them here and by times 100. Okay, we can take a look here. So we have a new column added. It's called percent. So as we group them by respondent word type, and it won't, the sum won't be across the whole rows. It will be only a sum by group. So here you can see this 3, the total will be 100. And segment, as we have only one line for segment, is 100. And then this group, that's total, it will be 100. And this is another 100. And here you can see it is grouped data. So it shows the group. It's grouped by word type. And it has 4 groups. And last time we mentioned that will be a good practice to ungroup before we send data to the next step. Okay, so here is kind of the plotting part, the visualization part. Here is the data. We already have percent ready for this Y. And when we run it, we will see this bars. Those are the kind of the percentage. This 3 together will be 100. How did I know that? We can remove this position and we run it again. We will see the 100. We
Dr. Wu, I have a quick question. So once we use the code group by, the character n is automatically generated by group by code? Because, yeah.
It is not generated by group by, it's generated by count. So you can see when we run here, you will see n is already generated.
Okay, okay, thank you, thank you.
So here we know we have only one house. It's built with cement. We don't really want it to be here. So we can filter this record out. So we can use the function filter and respondent word type does not equals to cement. And then we will use pipe to send the results to the rest of the code. And then it comes back and the cement is removed. If we want the position back, this is how it looks like side by side. And those are the percentages. So each kind of 3 bars there together, they will be 100. Any questions? Here we kind of put the plot kind of side by side for each village. Sometimes we may want to put them into multiple plots if we have a lot of villages. So side by side won't make them, yeah, if we have a large number of villages, those kind of side by sides will become difficult to read. And Ggplot 2 offers a feature called faceting. So we can kind of talk about faceting. We still can start from here. We want to reuse the code, so we can fold this. Instead of side by side, okay, we can add this facet. We can use facet wrap, and then the variable we want to use is village. So you can see here, it displayed in 3 plots. As we already put them into 3 plots, we don't really need the color. So they are of the same color now. So this is kind of the main content we covered for today, and I will quickly talk about customization. Customize the look and feel of your kind of final product. Let's say when you want to add some labels to your final product, let's say you can add the function labs labels, and you can add a title. So here we add the title to this plot. We can also kind of use one plot that will look a little bit easier. So we still have this title here. And also you can customize the x-axis and y-axis title. Currently, it's just automatically use the variable name. You can change it to the name you want. Let's say X. You can also kind of rename the field. it capitalized the V for village here. And now you see these titles are changed. You can also use the function theme to change some other kind of look and feel. Let's say I don't want the gray background. So you can add a theme black and white. And the gray background is removed. If you don't want the grid lines, you can also use theme. And great. And element blank. It will remove the grid lines. We can remove those redundancies. Let's say the border. Element blank, the same. So the border is gone, but also the x-axis and y-axis are gone. We can add them back. So this two axis comes back. You can also do other changes. Let's say you want to change the family of this font, of size of this font. You can, we can, let's say quickly. We want to make the title larger, let's say 20. So we get a large title. There's so many elements in the themes function. You can always use you can always check the help document. Did I? Okay. So here you can see those are all the possible elements we can modify. And sometimes it's difficult to understand the description, and you can always scroll down to examples. You can try those examples and understand those elements and how it works. We just covered a little bit about the visualization, and so we can in our guide, you can see here the RStudio cheat sheet. So Ggplot2, it has a cheat sheet here. You can, I think you can click, this will be a PDF file. Okay. It shows you different different charts and how to use them. And also there is a website, it's called R Graph Gallery. This is a very cool site. So you can start with, let's say, you can pick the chart type you want to create. Let's say scatter, we already see this one. Scatter plot. And this is use the Ggplot2 package to create. All those examples are created using the Ggplot2 package. And so you can see, you can change the shape of the points, and you can add those values, labels, and you can add different types of, this is kind of cool. You have those, you can click here and it show you the code. So this is just for Ggplot2. When you scroll down, this is base R. They won't use the same structure to create. So you can see this is scatter plot. It doesn't really, it did not use the Ggplot. This use the function plot. This is how the code looks like. And you can customize the shape. Okay. Also, for the tidy R and dplyr R, we also have the cheat sheet. I think these two links are the same. This is the cheat sheet for dplyr R, and this is for tidy R. So there are more functions we didn't cover. So those are the functions we haven't mentioned: slice, distinct, and this one kind of combine. You can bind columns, put two data frame together. This is kind of, how do you call that, horizontally, and also you can do that vertically. And this join functions, left join, right join, and yeah. Those are functions very useful when you want to kind of work with new data or different data sets. You want to put them together. On the guide, we also have the R community. R has very friendly community. Even you don't have a phone number to call people to help you, and you can always use this RStudio community and this tidyverse help documents. And sometimes if you have any questions or you see some error message, you can simply put the error message in the Google search box. And higher chances you may end up with the Stack Overflow, and you will see some solutions from other people met the same problem. That's kind of pretty much all for today. And I'm putting the evaluation
Got it in there. Oh, you
Well,
got it in there
oh,
too. We're
okay,
both fast.
Thank you, Cynthia.
Sure.
And if you have any suggestions or if you have any questions, you can come to us, always contact us, and we will send the recordings and the updated instructions next week.